Hi everyone, good afternoon. I'm Bo Shills. I'm with the AWS Water Infrastructure team, and I'm here to talk to you about some of the goals that AWS has set around water sustainability, provide a little update on how we're doing on that, and then share a little bit about how we're using AWS services to meet those goals, and then how you might be able to use AWS services to help meet your goals in the water sustainability journey. So very excited to be here today, and I'm also here in line with that theme, of course. I'm also here with Ash Chandran from the McCord Development Group, and he's going to talk a little bit as well on how he's using AWS services to help manage water at a utility scale for a development just outside of Houston, Texas. So thanks for joining. Before we dive into it, I'm just curious, quick show of hands, how many of you work for companies that have water sustainability goals or targets? Okay, good, a few of you, that's great. It's a growing trend. In fact, from 2022 to 2023, the number of companies that have set total water withdrawal reduction targets doubled. And today there's more than 1,500 companies globally that are actively looking for ways to reduce their water withdrawals. Water, as for those of you that have the goals and for those that are paying attention, water is going to be the next great environmental challenge of this century. Within the next 10 years, more than 50% of the population on the planet is expected to live in areas that will be impacted by water scarcity. So, what are we going to cover today? First, we're going to walk through the AWS goal. What is it? How are we doing? Second, we're going to dive into some of the 4 pillars of that goal. The first of which is efficiency. We're going to talk about what we did to establish a baseline for our water use, and then what we did to start driving down that water use. And in some cases, we had a little trouble collecting the data. And you can't manage what you can't measure, and so we decided to do some innovative work to bring IoT solutions to that problem. So we'll talk about that. And then we're going to touch on all of the efforts underway right now by the team to develop more sustainable sources for our operations. We, aside from being efficient, we're really focused on making sure that we can use sustainable sources wherever we can. Things like recycled water or on-site rainwater catchment. And then finally, we'll walk through an update on a couple of replenishment projects. The replenishment program is another key pillar of our goal that allows us to return more water to communities than we use in our direct operations. And so that is the goal. By 2030, we will return more water to communities and environment than we use in our direct operations. How are we doing? Well, we're very pleased to, this summer in our annual Amazon Sustainability Report, we were very pleased to report that we are 41% of the way towards being water positive. A lot of work has gone into that, and so again, I'll go through the pillars of the program. The first is water efficiency. When we started our program, we started measuring our water use and our efficiency, we were using about 0.25 liters per kilowatt hour. That's an industry standard measurement that allows us to compare against other data center operators. And that was already the lowest among all data center operators that report on that metric. And over the last 3 years, through a number of measures, we've been able to reduce that down to 0.18 liters per kilowatt hour. So that's less than a cup of water, basically, per kilowatt hour. In addition to that, the sustainable sources that we use recycled water is one of our key sources, and we have 24 facilities globally that are currently using recycled water. And then finally, on the water replenishment side, so far we have contracted or delivered 7 billion liters, or nearly 2 million gallons, of returned, that 2 billion gallons returned through our replenishment projects. So let's dive in a little bit into each of the components of the goal. Efficiency. Being efficient starts with an elegant and great design, and we have an excellent design. We do not have to use water for most of the year in cooling our operations. We can just take the outside air and push it directly into the servers. And across North America, we don't use water for more than 90% of the year. In some places like in Dublin and Sweden, we don't use water for more than 95% of the year. Only when the temperatures rise and the outside air temperature reaches certain points, then we add water to an evaporative cooling pad. And then as the air pushes through the pad, it comes out at a cooler temperature before it reaches the servers. And so, this design is simple, it's elegant, and what it does is it optimizes both the power and the water efficiency of our fleet. It allows us to use less power overall. So we have hundreds of locations and facilities and data center managers across the globe. They're all focused in their immediate communities on how they can reduce water. But they face challenges. It's not always simple to get timely and reliable data when you need it. And it can be a little difficult. Early on when we started the program, we were getting data from multiple sources. In some cases, we didn't have it ourselves. We were going to the utilities directly and getting the water use right from the utility. It took us a while to compile all that information, sit down with operators, explain to them, where the opportunities were to be more efficient. And, it just was cumbersome to quickly combine the data. And then, the other downside of that is that, sending all of this data over email and other mechanisms just isn't very secure and it doesn't scale very well. So we had to do something. So we introduced a program called Poseidon. What Poseidon does is it allows us to take data from thousands of sensors in our data centers that are connected to our building management systems and pull it into a central location in a very secure way. And what that does is it allows us also to take other data sources to aggregate sources that can help us inform operators on how much water, not just how much water did they use, but how much water should they have used. If you can ask an operator how much water they used at their facility. And they can tell you, they can go look at the meter and they can say, oh, I used about this much yesterday. But if you ask them, how much should you have used? They don't always know. Sometimes you get some blank stares and some head scratching. But what we've done is we've done the math for them. We've looked at the unique climate conditions. We pulled weather data from weather stations. We've looked at the water quality to see how many cycles we can get out of the water on site. And we looked at the IT load of their facility, and we combined all of that into one location, and then it gives them a central place where they can sort of look at their facility against others in the same area. And that provides that forum that we need for them to exchange information and learn from each other on how to reduce their water use and be more efficient. Very effective way to empower those local operators across the globe in one single place. So here's an example of what that looks like. What you can see on this graph is the orange line is the calculated expected use of the facility each day. This is a 30-day window that we're looking at for a given facility. And then the blue bars represent the actual water use. So as you can see, just looking at the graph, this side is actually performing quite well. So the operator can go about their day fixing all of the other things that they need to focus on in the data center to keep our servers up and available for all of our customers like you. Along the way, we had trouble collecting some data from a few remote areas of the campus. We have flow meters and such at remote locations throughout our data center campuses. And so what we did is we started running conduit and trying to connect them to the BMS. And what we found is it was just taking too long. It was months of work. You have to do some design work and you have to look at the ground. And and it was just very cumbersome. So we came up with an innovative solution. We built a custom gateway that we could attach to a variety of flow meters that simply takes the data from that flow meter and sends it over cellular backbone through MQTT protocols to our AWS IoT core service. And then from there, we took that and we used Lambda to sort of transform and push the data to our databases and our CloudWatch systems. And that data ultimately supplemented what we were getting from the building management systems. And we were able to install hundreds of these devices in less than an hour from the previous effort of several months. But we didn't stop there. You know, when you build dashboards, you have people that are going to look at the dashboards, but they may forget to look at the dashboard and see how is their site performing. And so we talk often at Amazon about building mechanisms that do not rely on the good intentions of people. And you know, we have excellent operators, but they have lots of things to balance throughout the day. So we created a ticket system that automatically notifies them when they're using more water than they should be. And then they're required to kind of go in and check the ticket, check the numbers, do a little bit of a deep dive to figure out what happened and then what's our action plan. And what that does is not only it allows them to focus on what they need to focus without having to worry about their water use until they get alarmed, it also allows us to have a great relationship with our utility partners. Because, you know, sometimes, you know, I don't know if any of you have facilities where you're using water, you know, sometimes you end up using more water than perhaps you wanted, and it can, you know, you can get an uncomfortable phone call from the utility. But with us, we're always prepared to be able to answer why, and in some cases, we're able to be proactive and just reach out to them and say, hey, we understand this facility is using a little bit more than it should be right now, but we're on top of it. We have a mechanical failure that we're addressing and should be resolved in the next few days. It just really helps that utility us earn trust with the utility. Okay, and so with all this that we built, what have been the results? Aside from all of the productivity gains of not having to collect all of this data manually and then send it out, it's all automated, of course. We've also seen a reduction in our water use per kilowatt hour by 28% since 2021. So very excited for the progress we've made on this. We have hundreds of automated tickets that are opened and closed each year, just to reinforce that importance of keeping an eye on our water use. And you know, we can manage all of our efficiency data in one place securely, which is also super important. You know, we talk often at Amazon about making sure we put the right data into the right hands at the right time. And the systems that we built are all scaled based on permission groups so that only the operators that need this information have access to it. On the sustainable sources part of the program, we're really excited today to announce some progress on that front. We are we have plans today to work with utilities to develop new sustainable sources like recycled water. Recycled water is basically effluent from a wastewater treatment facility that can be recaptured and put back to use for things like industrial cooling and irrigation and other safe and applicable uses. And what that does is it preserves the potable water for the community for better, higher purposes in the community. So we're really excited that we've worked on plans, and we have plans in place with utilities to deliver more than 1 billion gallons of recycled water to more than 100 data centers across the globe. So very excited. That's 4 times the amount of data centers that are currently using recycled water today. In addition to that, we're also looking at figuring out how we can capture more rainwater and use the rainwater in our cooling operations, which is a challenging thing to do. And so it's taken some time to get there, but we're excited for some of the developments that are happening there. And by 2030, we expect we'll have at least 10 locations doing that. And then finally, we expect to have close to 50 data centers by 2030, where the water, when we're done using it for cooling, our water, when it's discharged from our systems, is actually still clean enough to be repurposed and used in the community for things like irrigation. So we're also looking to expand on that. So the balance of the program, where we can't be more efficient and drive down our total water use, and we can't deliver recycled water because it's not always available, and where we can't reuse our cooling discharge when we're finished with it, we have our replenishment program. And the replenishment program is about watershed restoration, but we're giving water back to the community. And so there are a number of ways that we can do that. Well, one way is we help work with agriculture or utilities on finding system leaks and then helping them address those inefficiencies and sort of return the water. And Ash is actually going to talk a little bit about what they're doing on that front to find those water losses and address those. And so we are partnering with utilities to do that today, to sort of lessen the burden of our need to use water from that system. A couple of projects I want to highlight here on this slide. We just recently signed an agreement with a partner in California. They're a nonprofit by the name of River Partners. And what we're hoping to do there is we're going to repair native ecosystems in some of California's river corridors. So Central Valley salmon are not expected to survive the next decade without some decisive and scaled up action. And so to help address this challenge, AWS is contributing to a diversified portfolio of projects, 12 projects in total, that will include wildlife and habitat benefits, retired agricultural irrigation to help conserve water, and then reconnecting rivers to floodplains and side channels. If you think about how rivers are impacted over time through development, like if you look at where the Mississippi now enters into the Gulf of Mexico through Louisiana, the shape of that river has changed substantially. We build levees, we manage the flood, we do a lot of flood control. And that's happening, and that has happened in Central Valley as well in California. And so what this project is going to do is going to try to unwind some of that in a way, create side channels so that the salmon have safe and habitats to spawn and to repopulate and survive and thrive. So when this project is completed in 2027, they will generate more than 1.6 billion liters or 430 million gallons of volumetric benefit to the Central Valley of California. So really excited for that project. The second project is, there's actually two down in Latin America, and we're working with a company called Kilimo. Kilimo is Swahili for the word agriculture. And what Kilimo is, they're a climate tech startup, and they're also an AWS customer. And what they've done is they have created a model where they work with farmers to convert from flood irrigation to drip irrigation. And that saves an enormous amount of water. They install a new network of pipes, and all of the water is now delivered directly to the root system of the crops. And then using AI and a variety of sensors and automatic valves that exist in the system, they are able to assess when the plants have received the optimal amount of water and then simply shut it off. And that helps save millions of gallons of water. In fact, we expect it to save about 53 million gallons over about 160 acres of land in both Chile and in Brazil. So also very excited for this project when it gets going, and we expect to see results in the next few years. So I just listed an example of how we at AWS use our own services, but also the tech and the availability of technology from our customers. You've heard, I'm sure, many times throughout the week, and you will continue to hear that AWS has the largest network of cloud customers and partners, and we want to leverage them as much as we can to help us save water. So, to that end, we also started the Climate Pledge Fund in 2022, and what we do is we look for companies that, that we think not only might help us meet our own sustainability goals around carbon and renewables and water, but then how can they also help other companies and businesses? And so that's what the Climate Pledge Fund is for. A good example is with Subeka. We recently, they were one of the Climate Pledge Fund's first water company recipients. And they're actually an IoT company, but they're an IoT company sort of strictly focused in the water space. And they make a very handy register that can go on any flow meter. And then it sends the data in real time and in frequent payloads, over the Amazon Sidewalk network and also LoRaWAN. So it's a really interesting technology that we're excited to be investing in and then to use in our operations. And so, we also have an amazing AWS IoT and analytics team. Ash is going to talk a lot about how he's using IoT. Lots of development in this space, and we have an exceptional team. There's a session tomorrow that also is focused on how IoT is helping some of the water utilities in the UK manage their water use that I recommend that you check out in addition to what Ash has to say. So we're always looking for companies that are going to help us treat, recycle more water. Lots of great opportunities there. And I think I've probably talked enough now. So I'm gonna bring Ash up here. Thank you so much for being here and for listening. And I'm gonna hand it over to Ash, and he's gonna show you what he's been up to. So thank you.
Great insightful talk. I was listening very carefully when you talked about the design for the cooling. I can promise you, or I'm guessing, you don't probably have too many data centers in Houston because you would be using a lot of water. It was 90 degrees 10 days ago. So having said that, good afternoon, everybody. Thank you for being here. Ashwin Chandran. I'm the Director of Technology for McCord Development. I'm going to be talking to you about what we did. There are probably 4 sections that I'm going to be talking about. Who we are, what's the problem we were trying to solve, how do we do that, and more importantly, why we had to do that, right? So that's how I've structured the talk, and we'll get into it. All right. So McCord Development is a commercial real estate company, family-owned business, but it's the second largest landowner in the 3rd largest county in the US. So that's Harris County in Texas. They own 4,300 acres of land, all greenfield. So this is not very common, not just in the US, but all over the world. If you look at new development, it is not common to see a new development, greenfield development of this scale. So McCord's the private side of this. It's a private-public partnership. So they own the land, they develop it. The idea is not a standard commercial development strategy. Standard commercial development is just build, 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 sell, get out. That's not here. That's not what we follow there. It's to build a city that stands the test of time for generations to come. That's the idea, that we're going to build a city there, not just build, sell, and get out. So very different strategy. So it comes with a lot of different challenges as well. It's not, we don't have cookie cutter plans. It's all master planned, but it's all master planned, which is susceptible to change based on market pressures, based on how things change, because it's not, we're not getting out of there in 5 years, right? The development of this community started about 13 years ago when FMC Technologies, which was their anchor tenant, decided to build their headquarters there. So it's been going on for a while, and we still have a 25-year window. So it's a long-term development thing. And we are the private side. There's a public entity called the Generation Park Management District that collects taxes, issues bonds, all of those. So everything from roads, bridges, parks, trails, serving electricity and water, all of that is happening in this place. It's about quarter the size of Manhattan if you want to get some kind of scale for it, right? So, I come from oil and gas. I was in Houston doing oil and gas, building data systems, sensors for oil and gas. And then this came up, and I interviewed, and while I was interviewing, Ryan McCord, who's the president of the company, told me, hey, we want to build a smart city here. A smart city is such a nebulous term, means a lot of things to a lot of different people, right? Different things to different people. So I asked him, hey, what do you mean? What does it mean to you to build a smart city, right? So I'll give you a little bit of context. The whole idea of building a smart city started because FMC was going to construct their headquarters, and right in front of it, they built a beautiful, not FMC, McCord built a beautiful park with a trail around it, and there was a gravel parking lot right there. So they saw a lot of cars parking there, and I was like, well, who's parking here? How many cars are using this? That was kind of the first foray into trying to understand how the assets are being utilized. So it's really all about asset utilization. They put a pneumatic tube there, a car sensor there to figure out how many cars were parking, and they figured out that about 300 cars were in that parking lot every week, around average. So that is kind of what started a lot of things for McCord Development. One, two main things. One, parks and trails do have to be a central part of the ethos for building Generation Park because that's what brings people in. Two, we need to understand how our assets are being utilized to make better decisions. So that's how it started, but really about parks and trails, parking and traffic. These are the few of the different verticals that we really focus on to understand how they're being utilized, as well as to keeping privacy in mind. We don't really need to know who's using it, but what's the cohort behavior. So if somebody's shopping in a certain area, where do they tend to park? Somebody works in a building, where do they tend to park? Water and energy utilization, what are the different trends? What is peak? How do we shave peak to get to better utilization so that we are not, real estate is often built on peaks, and how can we reduce the peaks so that it's a more average use over time? Now, we started down this path, and one of the major challenges that we faced was silos, data silos, vendors, technology silos. Like, from a city perspective, there are thousands of services, and there are thousands of companies providing these services. How do we build something that is not going to be obsolete in a few years, that's not going to have lock-in, and still provide value and be able to replace parts when and where needed, whether it's technology, whether it's vendors? How do we do that? So that was one of the major challenges, and we'll get into that and how we did that. I'm not going to say we did it completely, but what was the strategy keeping that challenge in mind? All right. Let's talk about water, the real issue that we want to talk about today, right? So this is the what was the problem and why did we have to do it part, right? So to understand that, a few different terms that I want to introduce. One's water accountability. So operators, big cities have public utilities that manage their water. Now, small cities like us, especially in Texas, we contract out our water for private utility operators to come in and operate them. Typically, a really well-run facility can account for about 95% of the water they produce in the US. That's a really good metric. So that's accountability. Now, the other 5% is loss. That's water loss. There's another term called non-revenue water. That is where, 95% you can account for, but they can only bill their customers for maybe like 75% of it. The rest they cannot bill because of whatever reasons. The fire hydrant was left open, something like that. But just if you take Houston, a big city, 30 billion gallons of water loss, 35 million in repairs just in 22. That's the scale of loss that we're dealing with. Those are huge numbers, but believe it or not, it's not really something that moves the needle for a lot of big cities, because when you get to the bottom line, cost is not that much. compared to other things that they're running. I come from oil and gas. We tend to account for every molecule. And if somebody loses 30 billion gallons of oil, there's going to be departments that are going to be without jobs. So this was very, very non-intuitive to me coming in from a role where we had to account for everything. Unusually high water bills, and the scale is immense with a lot of issues in infrastructure, funding, all of those things that exist in our system, right? All right, so that is the what, and why did we have to do it? Now, Bo mentioned Subeka and other companies. We talked to a lot of different people on this path. We're a real estate company. We don't want to build services. We want to build buildings and infrastructure. Subeka was very much, one of the companies we talked to, they were very in their early stages and focused on California, did not want to work in Texas and take on another load. So we're like, okay, we have to do something. We can't wait around. So let's start doing something. Our district did not have any data that will help them understand how their assets were being utilized. So we had to build something that will bring all the data in first, and then try to make sense of it, understand that data, in forms of reports or whatever we can give the directors, as well as start building analytics on it, and then understand where are we losing it, what are the optimizations we need to do, all of those. So it all started with, okay, let's build the flow meter data in. We started with a brand new district, brand new meters, brand new infrastructure, go to the operator and tell them, hey, this is a brand new district, we need 100% accountability or as close as we can. They said, nope, you'll be lucky to get 85%. And that's really what spurred a lot of this, okay, we're going to start building something to understand what's going on here. So we built a digital twin for water distribution systems, and we'll talk about how we did it, what's the architecture, all of that. We wanted to build utilization and analytics, alarming and reporting, possible SCADA integration for plant management if we need to at some point, and then integrate also treatment, water quality measurements that are done in line at the plant. So the screen you see is kind of the hierarchical representation of our water distribution system. Our distribution system is not as complex like a city of Houston. It's pretty simple. We have about 250 meters. We have a plant. The plant's not instrumented, but this is truly an IoT platform. We can bring in any kind of sensor data into it, not just flow meter data. So the plant, if the pumps were instrumented, we could bring in the pump operational data and then figure out, if there are issues with the pumps and things like that. So it's truly an IoT data, and you'll see how that was built. So it's kind of and I'll go into the structure here. I think that's on the next slide. But this is kind of the landing page. We have a big system health monitoring section, which is drilling down a lot of different health indicators and diagnostics into one big metric to give the operator a quick view of, okay, this is our health, this is the health of the system, just a green pumping heart, and then there are components to it that they can drill down to see, okay, communication data status, and all of the device issues, anything there, is any of those turning orange, or is there issues with there? Now, one of the things that I mentioned before is high water bills. So we do something where each data point reported by every single meter is flagged whether it's a possible outlier or not. So that is by considering the history of that particular meter over the entire existence of that meter, as well as that meter along its cohorts. Like, let's say it's an industrial meter, or it's a meter for a restaurant. So we can compare it with other restaurants, other type of usage there, and then figure out, hey, how well is this data point with respect to others in that same class? So every data point does have a metadata tag that says, okay, is this a possible outlier or not? So we're not using that right now, but that's for, okay, how are we going to deal with any kind of issues that come up with data validation later on down the road? Right? So a quick, one of the things that are important to us as a growing district is capacity planning. So, I talked about asset utilization. We have one water plant, but we will have 2 or 3 later, right? When do we need to build that? We need to understand what our capacity is, how is it utilized, what's our peak usage, what's average usage, all of that. So capacity planning becomes important to us as a growing district because a new water plant is $10 million of investment. So whether we do that next year or 2 years down the road is really critical for us. So that becomes important, might not be as important to well-established, districts or town cities. We do have forecasting, and the bottom plot shows forecasting, and that goes into really the 90 degrees temperature 10 days ago. You see the green, I think that's green, that's the forecast, and blue is the actual usage. So for 24, you can see the blue line not really dropping down after September as the forecast said it would. Our summer, though not as bad as last year in terms of temperature, has been extended. It's really, last week is when it started to really cool down. So one of the things that tells us is the forecast model is not going to just look at history. It has to be updated. And we do have, forward-looking forecasts as well. This was a forecast that we do at the beginning of the year so that the city can plan for, or the town can plan for, how much water they think they would take from the city of Houston. Because we've got two sources of water, the city of Houston as well as our well. So we have to understand how much water we would take from the city of Houston. So that forecast kind of tells them what it is. So those are all the modules that are kind of built into it. I'm not going to read out all of those, but it is modular. So the way we built it is we knew that this is one of the pieces that we'll have to integrate with multiple other solutions. Let's take billing. We don't want to build a billing module. We can provide, and we have an API that can provide a billing module for people who would do billing. Service dispatch. And we'll get into anomalies and anomaly detections. Now, service dispatch is something that can be automated with an API. So it is built modularly with API integrations. Now, what were some of the benefits that we saw? Anomaly detection was clearly one of the big pieces. So back 2 years ago, when we started development on this, in November of 22, we lost 3 million gallons of water. That seems like a huge number, or at least to me it does, but it wasn't really. If you look at the cost, it wasn't that much, but when we lose 3 million gallons of water and the story is, hey, somebody backed up a truck to a fire hydrant and then left it open, it was the weekend, we didn't catch it. We're not being good stewards of resources we're supposed to manage at that point, right? So we can bring in historic data. So once the system was built, we brought in the historic data, ran it through the models. Sure enough, within the first few hours, we get the alert. That red dot that you see there, see on the right side, is there a pointer here? There is a pointer here. So that one, right? So that is an anomaly that was detected. So if we would have gotten an anomaly detection, we could have told the operator, because the operator is still not using it, and we'll get into that, right? So it would have been identified. We wouldn't have lost that water. Now, the plot on the left is more recent. So that's something that happened in real time. I say real time, but for water, real time is over days. So we got, in our non-potable system, we got an alert for anomalous usage, and then we can look at, okay, which of the non-potable meters have anomalous usage, and that's one of the things we'll build in automatically so that it's not just an alert. So we're also learning through this process about what to build, right? So we send the operator an alert, and they went and looked at, hey, it's behind this meter. So it's a small leak that was in a field, irrigation field. They went out, patched it. We still lost 1 million gallons of water over 9 days. It took 9 days because this is still manual. So, but now what we have is the power to tell our operator, they know that we know more than them about the system. And they are willing to listen to us. Now they've come to the table to discuss this and implement this in others. So we are going through a pilot where we will integrate another district, and we'll start that in January. So they're starting to see that, hey, we are knowing a lot more about the system than they can, and we can fix certain issues before they even know it. So it's starting to catch, but it's taken a while. All right, so how do we build it, right? This is the how part. And this, we started off, I'm going to say how we started off and where we are, right? So we started off with a data lakehouse architecture. I was just in a talk where they announced the SageMaker Lakehouse today, but this was before that. So this is a data lakehouse architecture. That's where we started. We wanted it to be device and vendor agnostic, having APIs to put input data into the lakehouse with API integration. So S3 with a federated query system on top of it, and then EC2 with Postgres and Python and React frontends. So basically the stack would be S3's EMR cluster and EC2's running the Postgres and the frontend. So that's where we started. And that worked very well for the system. This was how it ran during the development and for about 6 months, right? So where are we today? And this is the service that I wanted to talk about. It's the Garnet framework. So last year in November, I was at the Smart Cities conference in Barcelona. By the way, that's a great conference to go to. And I got connected with the Garnet development team in AWS. And that's an open source framework built around the Fiverr context broker. Fiverr is another open source consortium. They are starting to define data standards and getting into a lot of city-level deployments in Europe especially, and even some cities in the US. I know Austin's got a deployment. So Fiverr Context Broker takes in data in NGSI LD format, just like a JSON-based knowledge graph kind of structure. So you have entities, you have relationships, you have properties for all of those entities. So we have to define our water system or water network as an entity, property, relationship sort of nodes, and those kind of definitions for the water network. And then the Fiverr Context Broker ingests this. What Garnet does is it puts Garnet IoT from AWS and wraps it around the Fiverr Context Broker. Now you can connect all of your IoT devices to the AWS cloud using Garnet. And it will be in Fiverr Context Broker, provides a standard API to all services to query to get that data. So now this provides a clean platform for us to bring in all sorts of IoT data, get it context aware, and then provide a standard APIs to any third parties that we want to bring in to build any service on top of this. And it's easily deployable using AWS CDK. So that's a Garnet framework, right? So now this is the whole system. So there's the Garnet framework. We've got our flow meters sending out data, Lambda connectors, Lambda us to take that data, convert it into some format that we would need, and then push it into the framework, ingested by the context broker. And then we've got our front end did not change. So the data lakehouse structure that we had before was replaced by the Garnet, but our front end is still the whole thing that we built before. So this transition was not that difficult, and I'll go into how this transition happened, right? So really what this enabled us to do is, being a city, MizuWatch is the name of the service that we built. So MizuWatch, Mizu means water in Japanese, that's why the name is MizuWatch. So MizuWatch for water was built on this framework, but what this enables us to do is, being a city, now we can build in all the IoT data into the same broker, into the same system. And now we have a way of getting out of vendor lock-in and technology lock-in, right? So we can get this, because this is all open source at this point. So we can bring in the data, and we can bring in any third party, and all of these pieces become replaceable, right? So all of the IoT devices, whether it's water, whether it's parking, whether it's traffic, whether it's energy or lighting, we can all bring all of that data in, get it into this kind of a system, and then we start building our applications on top of it. Now, parking is another thing, and I hope I can be here next year to talk about the parking solution that we built out. It's amazing. It's really great. But I know too much about parking. everybody hates it. People who park, me and you who park hates it. The builders who build parking hate it. The cities who manage parking hate it. The only people who like parking are the parking consultants. Ask me how I know. Yeah. So it's a monopoly in a lot of different ways, and it's really difficult to get people to understand, hey, you don't have to do this. There's a better way of doing it. We can understand how parking is utilized, and same thing with water. A lot of the challenges come from the mindset and how it is driven and the lack of vision sometimes. So to talk to people, to tell them, hey, yeah, it's not moving the needle now because water is cheap, but that's not going to be the case. Bo mentioned this. It's going to be a serious challenge. How do you get ahead of it? I mean, we've got small governments. We've got really, there's a lot of advantages for that, local governments. But one of the problems is we sometimes lose sight of the bigger problem, because your problem in Generation Park, it's small. Added up over a year, it's still not that big of a problem. But take up all of the districts, small districts, all of the cities. Now you add it up, now that's a big problem. So we start building solutions, not in a holistic sense. We start building solutions that fix that particular problem. And sometimes it doesn't work well together. So how can we look at it in a slightly different way, understand that, hey, water might be cheap today, doesn't mean it's going to be. The environmental issues, the regulations that are coming down, how do you get ahead of that and figure out some of these solutions, right? So that's why, and that has been the effort to get it to a point where we can use, we've been using it for the past 6 months to a year, and now we're starting to get other districts and our operators as well interested for starting to use this so that they can be better. And the data is available, it's, why are you not using it, right? Right. So it would be a mistake on my part to not call out the people who made this happen, right? It's been a truly collaborative effort building this out, especially on the Garnet side of things. Garnet was new. It's still being built out. There were issues that we helped identify that was fixed and pushed out to the next release. So it's been a truly collaborative issue. Ali Hassan, who's a BDM based out of Houston, has been my primary contact, and he's been great helping me out in getting me connected with the right people. And Ali Ban Fatoum, who's based out of the Middle East and the lead on the Garnet project. And he worked with me personally to kind of get our project going and trying to get it all defined, fixing issues when they came up. So truly, truly collaborative effort. And thankful for having that help with AWS. That's really my talk. Thank you all. Appreciate you being here. Thank you.